All right, good afternoon, everybody. Thanks for coming. Hope you're not IBC'd out yet. We're from Polymer. We're going to show the Polymer protocol in action, a little demo, live. I'm Giuseppe. I'm been working in Web 2 networking for a while. So IBC is really interesting to me. It's kind of like getting to design internet protocols all over again. So it's really cool.
Yeah, I'm Nico. Hi, nice to meet you. I'm fairly new to the Web3 ecosystem. I'm only here for about a year. My background is in Linux kernel development, real-time video, totally unrelated world.
Do you want to?
Yeah,
handle the slides?
I'm gonna sit. Yeah, so I can. Yeah.
All right, so we're gonna probably go pretty quickly over the IBC architecture. What's relevant to this? You guys seem to all be very knowledgeable about it. Then a little bit more detail on the Polymer protocol and what we're going to show with a sample topology and finally a demo. Yeah, I mean, IBC, I guess we don't even need to talk about it, but basically, you know, the layers involved, and at Polymer, we strive to take advantage of the modularity and pretty much outsource the transport layer for chains that are not natively IBC compatible, and heavy focus on cross-chain dApp development. So we want to make it very easy for dApp developers to write dApps that are cross-chain compatible and just worry about their business logic and none of the transport. So yeah, this, I think you guys are all familiar with this, but what's relevant for us today is what Derek and we just talked about. So this is a single hop architecture, so you have connections and channels going directly end to end. And next slide, please. In the multi-hop architecture, you have the same for connections, but then you have a multi-hop channels that goes end to end, and so you will have like clients for each of the chains, counterparties on each of the intermediate chains, and that will play into how Polymer is structured to outsource transport. So the problem we're solving is basically not all chains support IBC, and so we came up with this concept of virtual IBC, where with a couple of layers, we're able to abstract the state from other chains and then offer protocol transport outsourcing. So in this diagram here, you can see there's a native light client at the bottom. So within the Polymer chain, we're able to actually run the native light client, for example, for Ethereum, and offer the same security guarantees as Ethereum, but do light client verification for the packets we receive. Then the next layer up is a virtual light client, which basically takes care of fork choice rules. Essentially, at the IBC level, as you know, like forks are not allowed, are not accounted for. And so with virtual light client, we're allowed to define security parameters, which allow us to make decisions on fork choice. And then, or maybe people just want finality, so we'll just deliver blocks that are finalized. And ultimately, at the top, you have the Polymer consensus, which kind of spans all the various like clients, regardless of which chains they're on. So all of these would be like different chains that we support. Okay. So how that ties together is the Polymer protocol. So essentially, this is again the multi-hop architecture, but on the left you can see it's slightly different. So you would have a virtual chain, which doesn't support IBC. So we have an on-chain smart contract that essentially mirrors the functionality of the IBC core module for chains that don't support IBC natively. And then we have our own flavor of the relayer, which is essentially picking up transactions to that contract and back and relaying them to Polymer. So once we're inside Polymer, we have this native light client, which allows us to leverage the security of the source chain, and then it goes into virtual and Polymer-like clients, which essentially, once you reach this point, you're in IBC world already. So we're able to have a multi-hop channel that spans these two connections. So it would be virtual to Polymer, and then this would be the light client of the receiving chain, and then the Polymer light client on the receiving chain. So, and this is like just an example of like virtual chain to IBC chain, but you can have any combination. You could have virtual to virtual and or the opposite, and it doesn't really matter. I mean, the architecture is the same. So on this end, this allows to just use the IBC relayer with multi-hop support and just treat all this side of the diagram as an IBC channel. So all this is like very complicated to adapt developer. They probably don't want to hear any of it. So that's why we came up with this IBC SDK, which essentially does all the bottom part of the diagram for you. And like if you're a DApp developer, you just come in with your DApp code and you don't worry about anything. So the SDK does, and Nico's going to show us in a minute, is allows us to bring up nodes for all the chains. Polymer, we consider Polymer an IBC hub, so we'll bring up Polymer as well. Configure the various paths on the various relayer, whether it's virtual IBC relayer or IBC relayer. Bring up all the relayers. Deploy the smart contracts that are required, whether it's the IBC core smart contract that we defined or the DApp developers contract. Then it creates all the light clients, connections, channels involved. This is all, as you can imagine, containers, so it orchestrates the containers and makes it easy for a DApp developer to get access to debug tools, logs, tracing packets, all that stuff. So today we're going to show a little demo. The architecture is very similar to the general one I just showed, except the chain on the left is going to be Ethereum. We're going to have on the right WASM-D with some pretty simple sample dApps on both, but we're going to show all the links shown in here. So we're going to have connections and a multi-hop channel, and then finally packets going in both directions from one DApp to the other. So without further ado, hand it off to Nico for the demo.
All right, let's see if it works this time. So what I have here is a TMOC session. Everything's going to be done in the terminal. We don't have any UI yet. So I'm going to be doing things a little bit different. I'm going to start the thing because it's going to take a minute. I'll explain what's going on, but I'm just going to.
IBC Control is like our first tool that we'll be releasing, and it essentially allows to do all the stuff I showed.
So I'm going to init what we call the workspace, and then I'm going to start this, and I'll explain what's going on in a minute. But again, this is going to take a minute. So the idea with the IBC SDK, as Giuseppe was mentioning, is to hide all the complexity of IBC, especially, and the Polymer stack to DApp developers. The idea is that you, as a DApp developer, you just care about your DApp, and you only care about writing the code you want to write. So if you want to use existing testnets, it's a bit of a pain because you got to get into the faucets, create accounts, create the testnet token. It's a bit in the back. So also, is not an environment that runs locally where you have a much faster development cycle. So what we thought of was, let's just put this in the hands of developers where they can run all the stack locally, and then they can just deploy their dApps very easily and iterate very fast, right? So that's basically what the IBC SDK is. We have two ways of interacting with the SDK. One is the CLI tool, IBCTL, which is the one I'm going to be showing today. We're planning of opening the API so developers can write automated tests on top of the SDK. That's probably going to come later. So again, while this is running, so what I did here, what I have here in the main pane is just the SDK doing its job. The panes on the right, I have the log of what the VIBC relayer to Ethereum is doing, the log of what the VIBC relayer to Polymer is doing. If you remember the slide from
the next screen.
Here. So those will be this VIBC relayer from here. At the moment, we have a split implementation. Probably it's going to take like that. we might change it in the future or not. We'll see. And here in the last pane, number 4, is just the IBC layer, regular IBC layer, right? Again, no UI, so bear with me. You're going to have to trust me that is doing the right thing. Right? Just a second.
Yeah, absolutely.
So what I did first was realizing that I hadn't removed the runtime files from the previous execution, but what I did first here, I'm going to just go to the main pane. I initialized the workspace. So what that does is creates a set of config files and the VIBC smart contracts within the workspace. This config file allows the developer to, I'm just going to go here, I'm just going to open the config file. Allow the developer to define the chains they want to run. In this case, is the font okay, by the way? I can read, yeah. So in this case, we are defining an Ethereum node, which is the Ethereum 1, the execution node. We also have an Ethereum 2 node, which is a consensus, Polymer, and as Giuseppe mentioned, the WASMD. In here, you can define the accounts you want to be created, the funding, and all sort of things. I'm not going to go into too much detail of this because we'll have a follow-up blog post explaining all that in detail. But just suffice to say that whenever you as a dApp developer, you want to start the environment, open up the config file, which is a predefined that comes with, and say, okay, in this case, I want to test my app in, I don't know, Ethereum to WASMD, right? So you just save it. And then what you do is you start the stack, right? So that is done, of course, with the start command. What the start command does is just reads the config file and it starts up all the chains that are defined there. You also configure the connections that you want to have. This is not an IBC connection. This is we are abusing the term here a bit. It's basically so the SDK can know how to set up the relayers and how to relay packets between the different chains you have. In this case, we're saying I want a connection between Polymer and Ethereum. I want a connection between Ethereum and Polymer, and I want a connection between WASM and Polymer, right? So this basically is just setting up the back and forth between Ethereum and WASM through Polymer, right?
Yeah, this is essentially bidirectional relay paths, and then the SDK figures out which relayer where and which endpoints, all that stuff.
Yeah, exactly. So the first thing that the SDK is going to do is start up the chains. It is taking a minute now because since we're running real Ethereum nodes, the node is actually merging, so it takes a few minutes to do the merge. We have plans to further optimize that, but if you, for example, were to use BSC, it only takes like a couple of minutes to bring up the whole stack. For BSC, yeah, it comes up in seconds, but for the whole stack, it's just a couple of minutes.
What's the nature of the data going between the VMs? For example, between WASM and EVM?
It's just
Do you guys
hello.
handle that? Or
It's
Yes.
your problem?
arbitrary messages, anything you
Right,
want.
but the VMs expect something, right?
Yeah, that's up to the dApp that's sitting on top of the VM to just decide.
Well, the dApp has to.
Yeah.
We just deliver payload, and then they figure out what to do.
What's the dApp's problem with the, make sure he speaks the language of the.
Yes.
Kind of, yeah. Yeah, to Polymer, all the packets that are going through is just opaque bytes. We don't even know. So once the chains are started, again, Ethereum takes a minute. The SDK just deploys the VIBC smart contracts on the Ethereum node, so the dApps can make use of it. It also starts the relayers in between. You can see that in here it started the ETH relayer, the IBC relayer, the ETH2 relayer. It creates the IBC connections, created the virtual client. Now, for the purposes of the demo, we're also deploying a smart contract on the WASM node. We got the address there. And then again, it does the 4-step channel handshake. So it creates an actual IBC channel between Ethereum and WASMD, right? So what I can do now is, for example, I can show you the state of the stack. So we do that with a show command, of course. So this is just a basic example. Hopefully we're going to make this a bit prettier. For now, we should see all the different nodes that are running locally with their container IDs. These are all Docker containers and the different endpoints, right? Using the names of the containers, I can run commands on the containers. Again, with in this case with the exec command. So I can say, for example, I want to query. Let me see. I want to query IBCTL exec. So I want to query the client states on the Poly node. Poly node is just the name. In this case, it's going to be Polymer. It could be Polymer 0, it could be Poly, it could be P. It doesn't matter.
Essentially, we plan to hide away all the container orchestration and just name nodes by name, and then people just have to be familiar with the IBC control command, which we're striving to mirror a lot of like the IBC commands, in the various chains, and essentially just IBC control takes care of the routing for you to the various nodes.
Yeah. So in this case, I'm simply running this command on the Polymer Docker container, so we can see that indeed it has created. So it has created the 07 Tendermint like client. It has created the 09 localhost. We have the virtual client that wraps around the native ETH2 like client. This is an IBC client. We also have a Polymer client that is part of the architecture, as we shown.
Yeah, Altair, if you're not familiar, is the ETH2 like client protocol.
I can show you, for example, the channels, how they were created. So again, this is coming directly from Polymer node. We have a channel 0 that has that is open. The counterparty port ID is the WASMD contract. Same thing on. I can do the same thing on WASM. Let me see if I can find the thingy. So I can query the channels on the WASM node. And again, another channel. Important to note, we have a multi-hop connection, right? So the WASMD node is making use of our multi-hop fork of IBC Go. So this is a true multi-hop channel.
What's the port ID on the Ethereum DevNet? Is it
So
only IBC Ethereum DevNet, and then what?
yeah, this is the address of the contract, just exified.
Okay. Looks long.
Yeah.
It's the full public key.
Okay, is that the public key?
No, it's the address.
Okay, so okay.
Yeah, right, I agree with you.
Okay, yeah, it looks like that's because like for the WASM one, look, okay.
Yeah.
I guess you just need to print the hex address instead.
Yeah.
Yeah, it's just a formatting issue.
Yeah.
So at this point, the environment is set up. So I have a couple of homemade scripts that talk to the chains, so we can send messages back and forth. So what I'll do is, so I'm gonna, for example, I'm gonna. So this script just listens for events on the Ethereum node. Again, I'm just gonna run it. It gets the endpoint and the contract address from the workspace. The workspace is here, so it knows where to listen and what to listen for. And on the other side, I'm going to just send a message to the WASMD contract running on WASMD. So in this case, I'm just going to execute the WASMD, again, my workspace, the contract address, the channel ID, which is that channel 0. And this is just some arbitrary data that I'm just going to send, which is hello from WASMD, and now it's whatever days is now. To your question earlier, this could be anything the dApp developer wanted to be. It could be a JSON, it could be anything.
Yeah, this is not part of the SDK. This is where the dApp developers
this-
tools and
Yeah, exactly,
code
exactly.
would take over.
That's why the coding.
Standardization.
So I'm just gonna run this, and what you're seeing here is, okay, this is a message that is going to be sending, right? The channel ID, the message, the transaction hash that I got from the receipt, again on WASMD. This is just events events that were emitted by the WASMD chain on this transaction hash. Well, you can. They don't matter as much. So this message goes to WASM. The IBC router is going to pick it up. So eventually, yeah, you can see that it's relaying one packet from WASMD to Polymer. Okay, so and then at some point the VBC relayer to Ethereum is going to pick it up. It's going to say, okay, I'm going to relaying from Polymer to the destination, and here's all the packets, and it ends up posting a transaction on Ethereum, and finally
That's from Polymer to Ethereum.
Yes.
Polymer to Ethereum, exactly. And then on Ethereum we get the packet, and so hello.
That's it, virtual or the native?
What is, sorry?
So you have the native clients
Mhm.
and then the virtual client.
Yes.
Who sends that?
That's the virtual relayer picks up the events from Polymer from the gRPC endpoint, and then gets approved for it and sends it back to Ethereum.
For the native light client, it's the full view of all the forks on Ethereum until justification. And each virtual light client that you deploy on top can implement some fork choice rule, whether the fork choice rule is I want doubly justified blocks. If I want something at lower latency, gotta pick a fork. Or choose some fork choice rule because it will be many forks. And you're allowed to define many virtual light clients over the Ethereum native light client. And you can establish channels over this, so each channel will have a different level of security.
Yeah.
Depending on like how you want to configure it. And the application can opt in on like, I'm sending $1 billion. I'm feeling less risky. Maybe I'm sending like $10 and I'm feeling more risky. So.
Yeah, but that only matters in the other direction.
Are the senders and receivers your contracts on each chain?
Yes.
Yes. So now the two contracts are linked via an IBC channel. Right. So then it's up to the app developer to have these contracts found each other.
Yeah, I guess you need to redistribute the
You
contract.
have to do the channel handshake.
Yeah.
So that's off chain. That is what you would initiate it on chain. So it would be initialized in the VM. So like one application would register itself, and it would get a port bound to it. Now it's considered like an IBC enabled module or an IBC enabled smart contract. Then that contract can then say, I want to do a channel handshake with some other contract in with an address. Yeah, port, connection IDs, like port. All this stuff is kind of which maps to a contract address at some point.
Yes.
Or an IBC enabled module. You can talk to either. It would work the same.
Yeah.
With your implementation, are there going to be like canonical addresses where people will access Polymer, or is the idea that you kind of spin up your own kind of access point?
The IBC core smart contract will publish the address and people will be able to use it too. Like we'll have one on each chain with support, and then people can address
people
it.
just will build on top of the one we run.
Publishing a formal specification for the IBC as well. So in the long run, we likely won't be this only implementation of the protocol. Hopefully, the community will be interested and can adopt it.
Yeah.
Just to wrap it up, I'm gonna demonstrate the other path from Ethereum to Polymer, WASMD, sorry. So I have a similar script that listens for events on WASM. I'm providing the WASMD contract address and where it's located. And from this side, I'm just gonna say send a message to Ethereum. Again, where the workspace is, the channel ID, and just random message that the contract on WASM understands. So we get an Ethereum receipt back. In this time, the transaction on Ethereum is going to be picked up by the IBC relayer that routes to Polymer. It's going to take a few seconds.
And this is where the native light client kicks in, verifies the transaction, then passes to the virtual light client, and then finally gets submitted to the Polymer consensus.
Yeah. Are these native EVMs and WASMs, or do they have to have been modified to know the IBC protocol?
They have to be modified to support multi-hop.
No,
there's
EVM won't.
no,
just
EVM no.
Yeah, just vanilla EVM chain.
Actually, for
Sorry,
ETH2,
that's EVM, sorry.
yeah, for ETH2 there was no light client implementation. We actually contributed the light client implementation to Prism, and that's what we're linking in our code. Since they're both Go, we're just able to use their implementation without, make any modifications.
Okay, so the IBC relayer relayed the packet to Polymer. Now the IBC relayer picks it up and relayed from Polymer to WASM there, and eventually it's going to make its way to the WASMD chain. Hey, there we go. So again, we have hi from ETH, the message. I'm just here printing the raw event and the channel ID and so on. And that's it. That's how you do IBC from EVM to WASM. Just to close it off, if I was a dApp developer, I would have set up the environment. Now I'd be testing my dApp on Ethereum and on WASMD, and I would find bugs and I would reiterate. I would redeploy them all the time or whenever needed, and without the need of restarting the stack. The stack is like if it was a real testnet on the cloud, but just running on your laptop, right? Eventually, though, you're going to be just done with it. So you just simply want to tear down and you just simply do at IBCTL stop, and you just remove the containers, and that's it. There's nothing running there anymore. So that's it. That's the demo. If you now
Any questions?
Yes. Questions?
Yeah, I just want to make sure. So your virtual Ethereum, I forget how you call it. Is that a SDK chain? Like what is that? Like,
That was on actually Ethereum node running. Actually, both Ethereum, like the Ethereum 2, they split consensus and execution. So we had Geth running for execution and Prism for consensus. And then the virtual part is actually how Polymer is able to abstract out the Ethereum consensus and then transform it in essentially an IBC transaction.
And where do you do that logic?
Inside
chain.
Polymer, inside
chain.
Polymer chain.
Inside Polymer.
Yeah.
Okay, so then my light client on WASMD is like depending on those parameters that you talked about earlier.
Yes.
I'm going to need a different light client depending on what parameters you choose.
Would be a different channel, right?
It would be a different channel. Polymer is verifying Ethereum consensus. At the state layer, it looks roughly the same. You have 3 chains. Each chain has a counterpart, and each counterpart keys make a connection. So it's ETH to Polymer, Polymer to WASM. WASM verifies the consensus of Polymer, and Polymer verifies the consensus of ETH. Whether that's via virtual IBC to Ethereum or a non-IBC native chain, or between IBC native chains, at the state layer, the setup is the same.
But how as like the WASMD chain, how do I like channels ultimately depend on a specific client, and this client is that security thing. How do I set up a different client?
Yeah, so the security parameter is actually transparent to the client. So with the channel, yeah.
So it's you only have one client to Polymer. You don't have multiple implementations.
You have one native client, and then you have multiple virtual clients, and then the virtual clients have different fork choice rules. One could say just wait for finality. One could say,
So
I don't want to wait
you
for
said the
finality.
channel.
Do it.
Okay, I think I get it. Yeah. Okay, cool.
I wanted to add that the intention of the IBC SDK is not just to be like Polymer specific tooling. It's supposed to be like open source and public good for all IBC enabled chains. It was something that some of our partners encountered when they were trying to build IBC enabled dApps across different chains. They encountered a lot of friction. I think the goal of this is to reduce that friction and like longer term, like we're thinking about stuff like, okay, what if we can take snapshots of the state of existing chains that are running, and you can now say, oh, I can test my app on a snapshot of the state of osmosis, connect it to something else, so you can test real-world use cases very quickly, because you can do like configurations like, what if I want to do fast iteration? I want to reduce the block times. Run one node, reduce the block times. So like, for me, I'm a dev developer. I just want the best dev experience possible while testing against like real-world scenarios.
Let's bring your own hub, but you have Polymer.
Yeah, and you can be a middle hub. You can do direct connections. You can set up the network topology how you want it and test whatever you want.
When can we start playing with this?
Yeah, we'll do a private beta. You guys can check updates on the Twitter, and then if next few weeks or so, we'll probably do a public release.
Congrats.
Thanks.
Thank you.